Thank you very much, Tony. How's the volume? Good in the back on this mic? Like Tony said, I work for the Corps of Engineers here in Seattle, and I'm going to give an example of a specific and applied study using some of this global climate change data that's available. So I wanted to give a quick plug for the Corps of Engineers National Program for Climate Change, and the website's up there, corpsclimate.us. That's the Responses to Climate Change program that's headed up in part by Jeff Arnold, who sits here at the UW. Jeff and the Institute for Water Resources for the Corps funded this study for Howard Hanson Dam and the Green River. Green River is in western Washington. This map shows both the Puyallup River Basin and the Green River Basin. You can see Mount Rainier at the bottom edge of that map that drains into the Puyallup. So the green is the next basin to the north. Flows out of the Cascades through some rural areas and then heads north through the second largest shipping and distribution center on the west coast, right behind Long Beach. That's the Green River Valley, before entering Seattle and the Duwamish Waterway and flowing into Elliott Bay. So Howard Hanson Dam was built in 1962 on the Green River. Main purpose is flood control. So our flood season in western Washington is mid-October through mid-February. And during that time, we keep the reservoir completely empty, except during floods as needed to store water. And our flood season goes through about mid-February, and then after that, we have this nice snowmelt runoff, and flood season pretty much wraps up, and we're able to use the reservoir for its secondary purpose, which is for what we call conservation water. So storing water in the spring and then using it in the summer to maintain minimum flows downstream. In addition, the Green River has long been a source of municipal water for the city of Tacoma, well predating the dam. When the dam was put in, it enabled the two systems to work together. That conservation water provided minimum flows during the summer, and Tacoma is able to take their water right without having as much of an impact on the river. Additionally, since 2007, there's been a secondary water right implemented for the dam, and we store water for the city of Tacoma an additional 20,000 acre-feet of storage that has been in place. Not an original purpose of the dam, but is now in place and follows the same timeline as that conservation water that we use for minimum flows. So just a reminder, flooding mechanisms in western Washington, it's all about these atmospheric rivers. And if you were at Cliff Mass's talk yesterday, he gave an unequivocal message yesterday that these were going to be more common and stronger. So that's not good news for flooding in western Washington. This study built upon some modeling done by several folks here at the UW. Eric Salate's work to dynamically downscale one of the GCMs for use in this region, and then some hydrologic modeling by Alan Hamlet, Matt Stumbaugh, and Si-Yun Lee to create daily flows for the Green River, both using the VIC model and DHSVM. So the result of their work was daily flows in 3 30-year periods, centered around the 1980s, as well as 2020s and 2050s for the Green River. And these hydrographs look a lot like the hydrographs that Amy Snover was putting up yesterday morning. More flow in the winter, less flow in the spring. And for Howard Hanson Dam operations, what we're concerned about is, do those higher flows in the winter during our flood season, are they from these atmospheric river events or in part from these atmospheric river events? It's not a big deal for flooding if it's 45 degrees and drizzling instead of 43 degrees and drizzling. And the snow level doesn't have a huge impact on flooding because, in fact, our current floods and our future floods, it never really snows in any part of the basin. Our floods happen in these really warm, you walk outside in the middle of winter and it's 55, 60 degrees and just pouring down rain. So those are the events that we're concerned about. And then on the flip side, in the spring, these reservoirs are emptied and filled every year. So constrained water supply in the spring does not automatically mean the reservoir is going to fall behind on its water supply. But if it's low enough, then there's not going to be enough water to take out of the system to reach that annual fill. So those are the two pieces that we looked at, flooding and refill. So I'm going to go through some results. Flooding, in terms of magnitude of flooding, what we're trying to do with Howard Hanson Dam is keep flow at the Auburn USGS gauge below about 12,000 CFS. That's the flood stage. Or that's the flood flow overtopping the levees in the lower valley, I should say. And when we ran this future data through our reservoir simulation models, the good news was that we didn't really see an increase in those 12,000 CFS and above. That doesn't mean that there weren't more events that natural flows would have caused the river to go above that level. And in fact, you can see the 9 to 12,000 CFS range in the regulated stream flows actually did increase in the future 2020s and then 2050s. And that, those are events where the natural flows probably would have caused flooding, but the dam was able to hold back enough water to protect against that flooding and then release the water later after the event has passed. So good news for a system like Howard Hanson with 103,000 acre feet of flood storage. Not so good news for other basins that would be similar to it, where they might experience these types of flood events more often, but not have the benefit of a flood control reservoir. The other piece of flooding that we were concerned about was the timing of flood season. So right now we have this nice distinct flood season and refill season, and we don't have to worry about starting to use the space in the reservoir during refill season because these atmospheric rivers have petered out by mid-February. So we're concerned, are these atmospheric rivers, is flood season going, particularly in the spring when we're starting to store water for other uses, is flood season going to encroach into that period? And again, good news, the hydrologic models did not really show increase large flooding in the springtime. There was one of the models that showed a few more March floods, but they weren't the big, juicy events that happen during our kind of traditional flood season. So moving on to the other purpose of the reservoirs, refill. So remember, there's two purposes of refill. One is conservation water for downstream minimum flows, and the other is for the city of Tacoma's municipal and industrial water. So first, looking at conservation water, our methods here is to start refilling around March 1st and targeting our full capture of about 30,000 acre feet, usually by the end of May, but we vary that date. If we have a heavy snowpack, then we might push it back into June. If it's a real dry year, we might target earlier in May. What we saw when we plugged this future climate change data into the reservoir model is that end target date for being full, for having captured that full 30,000 acre feet, is moving earlier in the year. So this graph shows the center of that target date kind of moving more towards mid-May, a lot less June targets, and that's just a reflection of the lower spring runoff. Good news again for Howard Hanson, using our current method of adjusting to what we see as a snowpack, it was actually very successful in capturing this 30,000 acre feet in the 2020s and 2050s data sets. However, if you're capturing the same amount of water, smaller amount of time, then the result is less water going downstream for other uses. So there might be impacts for fish or recreation uses there. And then also secondary uses such as storing this additional water for the city of Tacoma, this 20,000 acre feet that's been enacted since the dam was put into place. So we also looked at refill of that municipal and industrial water for the city of Tacoma. And these graphs show our current operations, so since 2007, of capturing that up to 20,000 acre feet of water for the city of Tacoma applied to all the 30-year data sets. So we didn't do this in the 80s, but if we were to apply current operations to the 1980s data set, we would successfully fill 100% of that 20,000 acre feet, maybe be able to do it every 9 out of 10 years or so. Moving forward into the 2020s and 2050s, that starts to look a little less successful. So every maybe 2/3 of the years or half the years. And then we start to get these years that pop in where we're filling less than half or maybe around half of that 20,000 acre feet of storage. So a clear impact from that constrained refill season there. So the next step is adaptation, right? So we were looking at how how we fill water for Tacoma, and right now we start filling on February 20th, so that gives them just a couple of weeks of head start where they're the only use of water, storing water in the reservoir before we start that senior purpose of that conservation storage in March. So what I did is I went ahead and modeled allowing Tacoma to start storing water earlier in the year, February 1st. They have a limit of 100 CFS per day, so those extra 20 days would make about a 4,000 acre foot head start on their 20,000 acre foot storage. When we looked at the flooding events that were present in the 2020s and 2050s data set, they weren't the types of flood events that would require the entire use or anywhere near the entire use of the reservoir capacity. So 4,000 acre feet sitting in the reservoir around mid-February, where we're still somewhat vulnerable to floods, did not appear to be a concern based on this flow series that we had available. So I'll show you what that looked like, just giving that 4,000 acre foot head start. There's still a discernible effect, definitely less successful in storing that additional 20,000 acre feet of water, but it's more like 75% of the years we can fill the full 100%, and those years where we're less than half have dropped off completely. So summary is we did see that higher winter flows, lower spring flows, but what did it mean for reservoir operations? Well, the higher flows maybe came with some increased flood events, increased atmospheric river events, but the current operations for flood control for Howard Hanson were able to absorb those additional events. But we're really still wondering about the effect that climate change is going to have on these atmospheric rivers. Those are the events that drive flooding in Western Washington. In terms of refill season, it was definitely compressed, but we were able to still fill that initial purpose of conservation water that the dam was built for. But that compressed refill resulted in taking a higher percentage of the water out of the river, still meeting minimum flows, but this is kind of one of those situations where maybe more water is better, and definitely more water is better for these other purposes that have been added to Hanson operations, such as storing water for the city of Tacoma. So that's the kind of area where these potential adaptations can continue to be looked at and possibly implemented in the future here. So with that, I will take any questions.
Hi, I'm Crystal Bach. I'm just curious if you've done any related studies similar to this for the Ballard locks.
For the locks, we have not. Yeah, so
Okay.
this was a pilot study funded by the Corps' national program. So it's the type of study. It's basically testing out an approach to be applied at the national level, and the Corps is really working towards implementing policies to look at this some type of analysis such as this for any of the water resources studies that we do. So maybe I think the idea is in the future it might be applied to all programs.
Hi, Kevin. Mike Grady. Thanks for your presentation. I'm with NOAA Fisheries. Any possibility we may need to reinitiate with you folks on our habitat conservation plan as it relates to changes in water levels behind the dam?
Yeah, I think I'm probably the wrong person to ask about that, but I know that I think we recently did a reconsultation or in the process for the basin to the south for the White River and Mud Mountain. So whatever process those take along, which I'm kind of removed from, I'm sure that those will be ongoing as we kind of see more information about what the future might look like.
Hi, I'm Ken Slattery, formerly with Department of Ecology.
Where are we?
Up here.
Oh, okay.
Way up here. And I recall that there were a few times in the 80s, 90s when the fall rains were late coming, and there were some really hard choices that had to be made about when to begin evacuating the reservoir, how much to stay, how much to keep in, et cetera. Did the modeling give you any insights into how that may change going forward in that part of the year?
Yeah, there were. The hydrology data sets did show a little bit of a shift towards earlier floods in the fall too. So these were not the biggest floods that showed up in the data sets, but there were times when we needed to hold back water a little bit later into March and a little bit earlier into October than we might have seen in the past. You kind of hinted at it. October, the end of the beginning of flood season, the end of the dry season is a little less worrisome because the hydrology in Western Washington is such that we just have this super solid dry time during the summer, and then when the rain turns on, it really turns on, and it doesn't. And basically, one flood event has a huge effect on the base flow in these basins. So, if once we get towards that time where we see maybe there's the potential for some floods, if we see one coming, we're not really concerned about releasing whatever leftover water we have. It's going to be a small amount. It's going to be easy to release within a day or two within that range of reliable forecasts for a flood coming in, and we're not going to really need to do it earlier than that. And then once that first one comes in, our base flows are going to pick up. That's what we've seen in the past, and that's what we continue to see in this data set.
So I want to thank everybody for your questions. If you have more, I apologize. Maybe if you can catch up with Kevin afterwards and talk to him directly, that would be great. Thank you.